Chapter 19, Developing Geometric Thinking and Geometric Concept. Geometry is a way to explore and analyze shapes and space. This critical area of mathematics appears in everything from global positioning systems to computer animation. Geometry involves developing and applying spatial sense. Spatial sense is an intuition about shapes and the relationship between them, and is considered a core area of mathematics study. It also includes the ability to mentally visualize objects and spatial relationships. In this model is a 5-level hierarchy of understanding spatial ideas. Each level describes the thinking process used in geometric concepts. Specifically, the levels describe how we think and what types of geometric ideas we think about, and what students can do. Learners of any age can begin at 0 and the progression to the next level through experiences through geometric ideas. Here are the characteristics of levels 1, 2, 3, and 4. Students at a level 0 recognize and name shapes based on global characteristics. A square is defined by a level 0 student as a square because it looks like a square. Appearance is the dominant at level 0. Students at level 0 may see a square with sides that are not horizontal or vertical and believe it is a diamond and no longer a square. The goal may be to explore how shapes are alike and different and use these ideas to create classes of shapes. A good activity with this figure here will be activity 19.2 on page 503, where you're sorting out the shapes based on certain characteristics. Level 1 students move from considering classes of shapes rather than identifying shapes by focusing on the properties of the shapes. Level considers all shapes within the class rather than just a single shape on their desk. Instead of talking about his particular rectangle, they can talk about properties of the rectangle. By focusing on the shape, students are able to think about what makes a rectangle, such as 4 sides, opposite sides are parallel, opposite sides the same length, 4 right angles, congruent diagonals. Irrelevant features fade away into the background. Students begin to understand that if a shape belongs to a particular class, such as cubes, it has considered corresponding properties of that class. In the figure on the right, 19.3 be a good activity for this, where you give a sheet similar to this figure to students and have the students list all the properties and classes of the square, parallelogram, rhombus, and rectangles. In level 2, students move from considering the properties of shapes to exploring the relationship between properties in geometric objects. Students begin to think about the properties of geometric objects without focusing on a particular object or shape. If all 4 angles are right angles, the shape must be a rectangle. If it is a square, all angles are right angles. Once students can engage in if-then reasoning, they can be classifying shapes by using only a minimal set of defining characteristics. Observations go beyond properties themselves and begin to focus on logical arrangements of the properties. The main part of level 2 is to emphasize logical reasoning. If, for example, if a quadrilateral has these properties, then it must be a square. Students should be challenged to use attributes to classify shapes. Make sure to ask questions such as, let's see if that is true for all other rectangles. Can you draw a triangle that does not have a right angle? Build upon activities around understanding and useful specific attributes of the properties, and for example, find ways to sort all possible triangles into groups. When moving from a 1 to a 2, make sure you ask questions that involve reasoning, such as, if the sides of a 4-sided shape are all congruent, will they always have it be a square? Do you think that will work all the time? What properties must diagonals have to guarantee that a quadrilateral with all these diagonals will be a square? Activity 19.6. What's my shape? Cut out a double set of two-dimensional assorted shapes on cardstock. Glue each shape from one set inside of a folder to make a secret shape folders. Glue the other set of shapes on cards and place them in the view of the reference. Designate one student as the leader who will hold the secret shape folder. The other students are to identify the shape in the folder by asking the leader yes or no questions. The group eliminates shapes as they get answers about the properties that narrow the choices from one shape down to one shape. Students cannot point to a piece and ask if is it this shape. Instead, they ask, does it have all straight sides? Is it concave? And so on. Composing and decomposing shapes. Students need to freely explore how shapes fit together from larger shapes composing and how larger shapes can be made smaller by decomposing. Students can compose drawings in order to study these properties of shapes. They can draw freehand with rulers, protractors, or even with technology. Geometric shapes with given coordinates. With composing and decomposing, you can use pattern blocks, transgrams, or Masonic pieces. Or they can use geoboards where they copy down other shapes, using rubber bands or string going around pegs. Here are categories of two-dimensional shapes and how they are described. By third grade, students must think about subcategories of quadrilaterals, and by fifth grade, they must understand that the attributes belonging to a category of a two-dimensional figure are also belong to subcategories. For example, a square is a rectangle and a rhombus. A parallelogram are trapezoids, but not all trapezoids are parallelograms. In this Venn diagram, squares are rectangles and rhombuses. All three are parallelograms. Parallelograms can be trapezoids, and trapezoids are also convex quadrilaterals. Here are the categories of three-dimensional shapes and the descriptions that go along with each category. Three-dimensional shapes have subcategories. In the figures below are examples of cylinders and prisms. Notice that the prisms are defined here as a special category of a cylinder with a polygon for a base. And the other figure shows a comparable grouping of cones and pyramids. Activity 1914, Mystery Definition. You can project a grade level appropriate logical problem on the board, such as the figures in the below. At the top of the sheet for the first collection, be certain that you have allowed for all possible correct options. For example, in the first grouping of squares is included in the set of rhombuses. Also, choose non-examples to be also close to a positive example, as is necessary to help develop a more precise definition. A third or mixed set should be also included in 9 examples that will challenge the students and have to confuse them. Use the class discussion of your students for justifications. The use of non-examples is particularly important for students with disabilities so they can distinguish between shapes and non-shapes of a certain category. Activity 1920, True or False. Students are going to prepare a set of true and false statements in the form of, if it is a blank, then it is a blank. All blanks are blank, some blanks are blank. Ask students to determine whether the statements are true or false and present an argument to support their decisions. For example, if it is a square, then it is a rhombus. True, a square can be a rhombus because they are both parallelograms and all the sides are the exact. Also, if you rotate a square, then it becomes a rhombus. If it is a pyramid, then it must be a square base. False. To be a pyramid, it does not have to have a square base. I think this because there can be triangular pyramids too.